Hello students, welcome to maths class. So we are doing reduction problems in integrals, isn't it? So what is meant by reduction formula? I said we will find some general form of the some standard values previously sin to the power of nx, right? We got some general equation that is called a reduction formula for integral sin to the power of nx dx. So once we got that formula, if we want to find integral sin to the power of 6x, sin to the power of 8x, sin to the power of 10x, we can easily find just by substituting n value as 4, 6, 10 in that reduction formula, right? So by using this method, we will derive one standard formula. That formula is called a reduction formula for some values. Then after using that reduction formula, we will find the integrals of same type of problems, right? So that way we will use this reduction formula. So sin to the power of nx is over. Now we will find, so actually sin to the power of nx is over now. So you can solve same by using that method. You can solve cos to the power of nx dx. You can take that as a homework problem. Find the reduction formula for the integral cos to the power of nx dx, right? Sin and cos problems will be same reduction formulas, right? Just in place of sin you have to take a cos and method will be same, right? Now we will solve a tan, right? Tan and cot problems will be same method solving, finding the reduction formula for tan to the power of nx dx and cot to the power of nx dx will be same. Okay, so come on, now take the question integral tan to the power of nx dx. First you have to find the reduction formula, then you take the integral tan to the power of 6x dx. Okay, so come on, how we will find? So we will consider that value as power is n now, and previous question in yesterday's problem, we have taken whenever power is n, I have taken in integral, right, which is having power as n, that is the meaning, right. So is equal to, tan to the power of nx or tan nx, both are same. Okay, so here I am doing tan to the power of nx multiplying and dividing with tan square x, right? We are multiplying and dividing with tan square x dx. Okay, so next step you write integral tan to the power of nx, right? By this tan square x comes along this one and this tan square x remains as it is, right? So now it is of the form a to the power of m by a to the power of n form, a to the power of m minus n. So it is tan to the power of n minus 2x, right, into tan square x into dx. Okay, so next is equal to, we can write this as tan of n minus 2x. Tan square x can be taken as secant square x minus 1. By trigonometry, there is a formula from the identities, right? We can write in place of tan square x, we can write secant square x minus 1. Right, now write separately, multiply first, right, then you take the integrals separately. This is your in, right? In is equal to integral of tan of n minus 2x into secant square x minus tan of n minus 2x into 1 now, so that one only into dx. Okay, so just we multiplied this with this, next this with this. Now if you observe, we are having minus sign inside the integral. Whenever plus minus, we have to take separate integrals. So it is in is equal to integral. Come on, how we can take this as tan of n minus 2x secant square x dx minus tan of n minus 2x dx. Okay. So now if you observe carefully, we can take here, if we take t is equal to tan x and differentiating with respect to x on both sides, dt by dx, d by dx of tan x is secant square x, right, secant square x. Then what will be your dt? dt is equal to secant square x into dx. Okay, so here instead of this secant square x dx, we can take the value as dt. Okay, so therefore what will be your in now? So in is equal to integral of, come on, what is this? Tan to the power of tan of n minus 2x or tan x to the power of n minus 2, both are same, that is t, right? So we are having t to the power of n minus 2 into secant square x dx is dt. So in its place we will write dt. Okay, so next minus, observe carefully, integral tan to the power of n minus 2x. So we have taken in is equal to tan to the power of nx. If power is n, I have taken in. So if power is n minus 2, this can be written as in minus 2. So tan of power is n minus 2. So we can write this as in minus 2, right? So in minus 2. Okay, so this value is integral tan of n minus 2x dx is in minus 2. So now this one, what is this? X to the power of n form, power is having, right, any variable is having power means we have to go for which formula? Integral x to the power of n, where x is variable. Instead of x we can have any value. So instead of x we are having t here. So integral x to the power of n, what is the formula? Integral x to the power of n dx is equal to x to the power of n plus 1 by n plus 1. So instead of x we are having t, right? So here it is t to the power of n plus 1, n minus 2 plus 1 by n minus 2 plus 1 minus in minus 2. Okay, so is equal to, what happens to your value? T to the power of n minus 1, minus 2 plus 1 minus 1 by n minus 1 here, right, minus in minus 2. Okay, so this is your in. Okay, so come on, now in t place we have to substitute value, original value. So in is equal to, what is t? We have taken t is equal to tan x. So we can write this as tan x to the power of n minus 1 by n minus 1 minus in minus 2 is the reduction formula, right, is the reduction formula. So we have to find the reduction formula for the given value tan to the power of nx. After that, by using that reduction formula, we can find so many values, tan to the power of 6x, tan to the power of 8x, tan to the power of 10x. Just in place of n, if we put 6, 10, 8, we will get different values, isn't it? So that is the meaning of reduction formula. We will find one standard formula for the some values. After that, by using that formula, that reduction formula, we will find the integral of same type of problems, right? So now we have to find integral tan to the power of 6x. So therefore integral tan to the power of 6x dx. So if it is tan to the power of nx, I have taken in. So if it is tan to the power of 6x, which value we have to find? I6. So in this reduction formula, wherever n is there, we have to substitute 6. Okay, so is equal to, how we will substitute? It is tan x to the power of n minus 1, 6 minus 1, that is 5 by n minus 1, 5 minus I of n minus 2, 6 minus 2, right? N is 6, right? So 6 minus 2 is 4. So again I4 we have to find in the formula. Wherever n is there, now we have to substitute 4. Okay, like a chain, isn't it? So it is tan x to the power of 5 by 5 minus, come on, now in this formula we have to substitute in n place 4 we have to substitute. So it is tan x to the power of n minus 1, 4 minus 1, that is 3 by 4 minus 1, that is 3 minus, come on, I n minus 2, n is 4 now, 2 minus 2, right? Isn't it? Here I n minus 2, here n is 4, so I 4 minus 2, that is I2. Okay, n minus 2, n is 4, 4 minus 2 is 2. Okay, so is equal to next value, it is tan x to the power of 5 by 5 minus tan x whole cube by 3, minus of minus plus, right? I2, now in that formula in the n place we have to substitute 2. Why I am laughing? Again and again we are using the same formula. First we substituted 6 in that formula, then we substituted 4, now we have to substitute 2 in that formula, right? So come on, it is tan x to the power of 2 minus 1 is 1. So tan x to the power of 1 means tan x only by 1, right? 2 minus 1 is 1, right? Minus next I 2 minus 2. Now your n is 2, formula is I n minus 2. So 2 minus 2 is 0. Okay, so is equal to, now it is tan x to the power of 5 by 5 minus, next we can write this as tan x whole cube by 3 plus tan x, okay, next minus I naught, I0, how we will take? In is equal to tan to the power of nx dx, right? If power is n, we have taken in. If power is I0 means power will be 0. So what is that value? Integral tan x to the power of 0 into dx we have to find. So any value to the power of 0 is equals to 1, right? So this is tan x to the power of 5 by 5, okay, minus tan x whole cube by 3, okay, plus tan x, okay, minus any value to the power of 1 is, any value to the power of 0 is 1. 1 into dx is dx, integral dx is x. So after getting the all answers, all the terminology, that means after the completion of integrals we have to write plus c. Okay, so that is the answer of your question. So in all these reduction problems or formulas, first we have to reduce some standard form, right? Tan to the power of nx, we got one standard formula, right? Reduction formula. First reduce it. By using that formula we can find a similar type of integrals, right? Tan to the power of 6x, tan to the power of 10x, tan to the power of 8x, like that we can find the values. Similarly sin to the power of, in previous class we got the reduction formula of integral of sin to the power of nx dx, right? Once we got the reduction formula we can get a sin to the power of 4x or sin to the power of 8x, sin to the power of 9x. Just just substituting the n value in that reduction formula. Okay, so that is the concept of this reduction formula. So sine I have given, no, you can do cos, same procedure, multiplying and dividing with the cos, then you apply your product form, right, formula, then you will get it. Here I did tan, no, so you can solve your cot, same multiplying and dividing with the cot square x, and same procedure you can follow. Okay, so if you know how to solve sine to the power of nx, we can find cos to the power of nx. If you know how to find tan to the power of nx, we can find cot to the power of nx. If we know how to find the secant to the power of nx, we can find the cosecant to the power of nx formula, same method, right. I will give one, you have to solve another one. Okay, so be clear with the concept, right. See, actually once we got the reduction formula, again and again we are using same reduction formula. Here first we substituted, we want I6, it is asked tan to the power of 6x, that's why if in is equal to tan to the power of nx, if power is n, we have taken in, if power is 6, we have to find I6, right. So I6 is the value. Okay, so if we want to find I6 in the reduction formula, wherever n is there, we have to substitute 6, right. Then we got I4, same in the reduction formula, wherever n is there, you have to substitute 4. Then again I got I2, I2 means again in the reduction formula, wherever n is there, you have to substitute 2, right. Then you will get your value. Okay, so not only tan to the power of 6x, suppose tan to the power of 8x, tan to the power of 4x, anything we can find once we derive the reduction formula. So reduction formulas are useful in finding the other values which are of same type, which are of similar type. Okay, so that's why you have to find out. And here one thing you have to remember, here I multiplied and divided with the tan square x, tan square x. In previous question we multiplied and divided with the sin x, right. There we applied the product form. Here no need to go for product form, directly tan square x we are having, right, by identity secant square x minus 1 formula is there, right. So just you take a secant square x and separate it, right. So once you separated, if you observe this one, we know that this value is having power and into secant square x is there. So if we differentiate the tan x, we will get the other term. So whenever situation is like that, we will go for our substitution. That's why I have taken t is equal to tan x. So in previous problem you have to remember, we have to multiply and divide with the sin x, but in this problem we have to multiply and divide with tan square x. Why? We can write tan square x as a secant square x minus 1. Then after separating, by using substitution only we can solve this one. And here whenever in is, suppose term is having power n, we have taken in. If the value function is having power n minus 2, we will write in minus 2. Suppose the function is having the power as n minus 1, then in its place we will write in minus 1. Okay, so that is the thing. So if power is in, power is n minus 1, in minus 1, power is n minus 2, in minus 2, like that we have to take, right. So if you practice once or twice, you will get it, right. Simple only. Okay, little bit lengthy, but they deserve 7 marks questions, no. So that much lengthiness they deserve. Okay, so practice this problem perfectly. That's all for today. Have a nice day.